name is Michael O'Halloran. I am a senior software engineer and a lead instructor at Codesmith LA. Tonight, we are going to be talking about promises, asynchronous techniques, and the event loop in JavaScript. If this is your first time, please turn on your camera and update your name to your first name, where you're tuning in from, and that way I can call on you, because tonight you're going to have the opportunity to practice your technical communication in front of a bunch of other JavaScript students. We, of course, are super supportive here. We could not care less whether you get the right or the wrong answer. We only care whether you try or not. Don't worry if you get the wrong answer, we will clear it up. And guess what? By getting the wrong answer in front of a bunch of people, you will learn that lesson very, very, very well, and you won't make the mistake again. I promise you. I absolutely promise you. There is no one here who is judging you. And if anyone here is judging you, they don't matter. Cool, groovy. If you judge someone, you walk it, as my grandpa used to say. That said, y'all, here we go. Okay, so promises, asynchronous techniques, and the event loop. Tonight, we're going to be talking about promises, which really are what many will argue the most significant ES6 feature, ES6 being ECMAScript's 6th iteration. We'll get into that in a little bit. Asynchronicity, what do we mean by asynchronicity? Well, something that is not synchronous. Thanks for the definition in the definition. Synchronous is something that happens in order. At least when we're dealing with JavaScript or with programming, synchronous code is code that happens in order. So I execute line 1, then I execute line 2, then I execute line 3, then 4, then 5, etc., etc. Asynchronous techniques are where we figure out ways to execute maybe lines 1 and 2, then skip down to 25, then run 26 through 398, then go back up to line 3, and then run all the way to 24. Now, why would we want to do this? Because many tasks that we do on the web involve waiting for something else, but we'll get into it. How would we possibly make this happen? Well, we use what's called the event loop. I like to think of the event loop as a nervous wedding planner, something that is running around with a clipboard, checking to make sure everything's okay, and if anything else needs to happen. If you suffer from type A personality, you know what's up. You and the event loop are soul sisters. Finally, we're going to talk about the microtask queue, the callback queue, and web browser features, the places where things wait until it's their turn to be called by the event loop. Cool? Cool. But first, before we can get into anything like that, we got to get a working vocabulary in JavaScript. Okay? So if this is your first time ever at a Codesmith event or at JavaScript The Hard Parts, what's about to happen is going to be scary and uncomfortable. But I encourage you to stick around, keep breathing in through the nose, out through the mouth, let it wash over you like the beautiful glory that the universe offers. Cool? We're going to be talking about 3 main things introducing proper, clear, concise, precise technical communication tonight. So, functions. Functions in JavaScript are merely sets of instructions that we save for later. So think about it. If you have the process of how to make a peanut butter and jelly sandwich in your head right now, think about it. You have the instructions. It's go get the bread, go get a knife, put some jelly on one, put some peanut butter on the other, put the two together, enjoy, right? Similarly, in JavaScript, we store instructions like that with a label. So for the peanut butter and jelly recipe, it would be make peanut butter and jelly. We store it with a label and we call that a function. And then at any point that we want, after describing what that function is supposed to do, we can invoke that function. So if I were to then myself stand up, go to the kitchen, get 2 pieces of bread, get the jelly, get the peanut butter, that would be me invoking a function. The function definition being the instructions that are saved in my brain, and the invocation being me actually carrying out those instructions. Cool? Cool. Next, we have the thread of execution. This is going to be a big deal tonight, y'all. The thread of execution is the thing, the process that goes line by line to actually execute JavaScript code. So if we were thinking about my peanut butter and jelly example, first the thread would enter the execution context of peanut butter and jelly. It would go get bread. It would then get knife. It would then put knife in jelly jar. It would then spread jelly on bread, etc., etc. That thread of execution goes line by line by line in JavaScript. JavaScript is a single-threaded language. That means that there is only one process that can be doing anything at a given time. So unlike our human brains that are capable of multitasking, JavaScript is not capable of multitasking. It only has the one thread that can only be doing one thing at a time. And so tonight, we're going to be looking at how to manipulate that thread so that it does things in the correct order. So it seems like it's doing multiple things at a time. Okay? Again, super important. JavaScript is a single-threaded language. The thread that I'm referring to is the thread of execution, or the process that goes line by line executing code. Cool? Finally, we have what's called memory. Most likely, you can infer what memory means. It is a location in our computer where we store labels and values. So going back to our peanut butter and jelly example, the label peanut butter and jelly, the name of our function, would be stored in memory, and we would store the instructions related to that label. Similarly, we can store what are called variables, which are just labels for pieces of data. And we're going to get into that. We're going to get into that in a bit. But that said, the really important stuff to know before we keep moving on is that we got functions, which are sets of instructions for JavaScript. We got the thread of execution. JavaScript only has one, and it's the process that runs line by line to execute our code. Execute just meaning running. And finally, memory, a location where we store keys or labels and their associated values. Cool? Cool. Now, if we look at this code example on the right, we are going to have a fantastic opportunity to just get some common lingo between ourselves. Cool? So in this code, I am going to declare a constant variable with the name num and assign it to the integer value of 3. I am then going to declare a function definition with the label multiply by 2. Multiply by 2 will take one parameter called input number. Next, I'm going to declare a constant variable called output, and I'm going to assign it to the evaluated result of the invocation of multiply by 2, passing in the evaluated result of num as an argument. Finally, I am going to declare a constant variable new output and assign it to the evaluated result of the invocation of multiply by 2, passing in the argument 10. Okay, groovy. Let's boogie y'all. Now, if this is your first time, the way that we diagram stuff at Codesmith, I'm sorry, stuff is probably the worst technical communication I could use. The way we diagram at Codesmith is we actually draw out our variable environment and what is happening within it. So anytime we are executing JavaScript, we have a global execution context. That execution context is literally just the environment in which we are executing or running our code. Now, we have a pretty common way of diagramming this stuff. In our global execution context, we have that memory we were talking about, which is our global memory. I'm gonna get a skinnier pen. And we are going to keep track of all of our variables and their associated values while we're actually diagramming through this. Now, remember earlier, I was talking about the thread of execution and how JavaScript can only run one thing at a time. Well, JavaScript has what's called a data structure that keeps track of what is being run at each given moment in time. This data structure is referred to as the call stack. The call stack is just a stack of functionality. You can think of it as a stack of plates or a stack of pancakes. And what it does is it just keeps what is being currently executed at the top of the stack so that we know what is being executed. Now, each running process on the call stack we refer to as a frame. And at all times, we have the global execution context on the call stack. Now, I have abbreviated it as G with parens to show that I am invoking that global execution context. Now, what we're going to do is we're going to assign variable labels and values, push items onto the call stack, pop them off when we're done with them, and see what this code is actually doing. Is there anyone here who wants to take a stab at communicating through what is happening? Awesome, love it. Lindsay, while you get geared up, I should have said this at the beginning. Y'all, there is, at the bottom of your screen, there's a reactions button. If you click on the reactions button and choose raise hand, you will be able to, imagine that, raise your hand. That will actually demonstrate or show a hand raised on the slide, or I'm sorry, on the screen itself, and I will know that you are raising your hand. If you use the raise hand feature, I can see what order people were raising their hands, and it will make it easier for absolutely everyone. Cool? Lindsay, that said, take it away.
Sure. We're starting on line 1, so we'll start with that. We're going to make the constant variable called num in global memory, and we're going to assign it a value of 3.
Spectacular. Okay, what's next?
Number 2, line 2, we're going to make a function. It's going to have the label multiply by 2, and it's going to be assigned a function definition.
Spectacular. And where are we going to save it?
We're going to save it in the global memory as well.
Spectacular. And it is a function definition. For those of you not familiar, this box with the arrow through it is literally just shorthand for a function definition, which keeps track of all of this code in here. Okay, so this with a label. Cool. Lindsay, let's keep rolling.
Great. And because all of that is in the function definition, we can skip lines, well, the rest of 2, all of 2 to 6, and we can start on line 7.
Spectacular. What happens now?
Now we're going to make a constant variable called output in global memory, which will be assigned. Well, we can do that afterward.
Cool.
Great, and it's going to be assigned the invocation, the result of calling multiply by 2 with a parameter of num, but we don't know what it is yet.
Spectacular, spectacular, spectacular. So we don't know what it is yet because we have to invoke this function first. Now, y'all, when in JavaScript, when we're invoking a function, we need to open up a new execution context, which means we have to open up a new, smaller version of the screen that we're looking at right now, a new environment to execute this stuff in. From here on out tonight, when I say in JavaScript, when we invoke a function, we must open up a new and pause. Everyone must unmute and yell execution context. Don't ask me why. It's just the way we do things. If you don't do it, I'm going to call you out for it. So just do it. If it embarrasses you, just go ahead and do it, because otherwise I will embarrass you. I promise you. Cool? Groovy. Okay, spectacular. So Lindsay, we need to evaluate the result of invoking a function. So in JavaScript, we're going to open up a new what, Lindsay?
Execution context.
Execution context.
Execution context.
Execution context.
Beautiful. Beautiful. Okay, Lindsay, so we've opened up a new execution context. So what happens next?
I guess, do we want to talk about the thread of execution kind of threading into that context too?
Sure, I'd love to talk about that.
Okay.
So our thread of execution actually enters the execution context. And then what?
Great. And then the first thing we do is we're going to pair our arguments and our parameters.
Spectacular. So we have to pair our arguments with our parameters. And where does that actually happen, Lindsay?
It happens in the local memory.
Spectacular. So the memory that is just for this execution context. Now, Lindsay, what are our arguments and what are our parameters?
The argument is num.
Spectacular. And what is the parameter?
Right, and the parameter is input number.
So spectacular. Okay, so y'all, we have special words for the input to a function. So if we are talking about a label for or a placeholder for data that will be put into the function, we use the word parameter. Placeholder parameter. P placeholder parameter. Cool? If we are talking about the actual value that has been passed in, here num or 10, it's an argument. Actual A argument. P placeholder parameter, actual A argument. Cool? So we are pairing a placeholder label with an actual value. So as Lindsay said, our parameter is input number. And what is going to be the value of that, Lindsay?
The value of input number is going to be the value in num, which is 3.
Spectacular. So it'll actually be the evaluated result of evaluating num, which is when we look in our local memory, num is equal to 3. Cool. So spectacular. 3 gets passed in. Then what?
Well, before we continue, I forgot something, which is it needs to this execution context, the function invocation needs to be pushed onto the call stack.
Spectacular. So y'all, when the thread of execution enters an execution context, a new frame gets pushed onto the call stack. And now, remember I said, whatever's on top of the call stack is whatever we're working on. We can see that we're actually working on multiply by 2. The thread of execution is actually in the execution context for multiply by 2. Okay? Now, the thread of execution entering and the frame getting pushed onto the call stack happens relatively simultaneously. We don't need to disambiguate between which happens first. Okay? However, just know that if the thread is in the execution context, that it's what's on top of the call stack. If it's what's on top of the call stack, the thread is in that execution context. Cool? Cool. Spectacular job, Lindsay. So what happens next?
Okay, so we have, we paired everything up. So now we're going to actually do the stuff in the function definition. So that would be line 3.
Cool.
Great. Line 3 says we're going to make a constant variable called result. And it's going to have a value of input number times 2. So
spectacular. And where are we declaring result?
Result is going to be in the local memory.
Spectacular. So result is equal to, and we got to do a little bit of a calculation. So it's equal to, so what is input num, Lindsay?
3.
Spectacular. So we look in our local memory, we can see it. It evaluates to 3. 3 times 2 equals 6. And then finally, what happens at the end, Lindsay?
At the end, it's going to return result. So we're going to return that value to the output variable that we made in global memory.
Spectacular. So we hit this return keyword, which tells us to take the evaluated result of the results keyword and return it out, and it becomes the actual value. This is the evaluated result of invoking multiply by 2, passing in num as an argument. What else does the return keyword do, Lindsay?
The return keyword pops that execution context off the call stack.
Spectacular. which means that what goes where?
It means that this local execution context gets like basically garbage collected.
Spectacular, absolutely. First, the thread of execution leaves, and then the execution context gets garbage collected. Cool? All of that just for that little line. Now, similarly, we're going to have a very, very similar process for line 8. So what would happen is we would have new output. Oops, it's red. We would have new output declared in global memory. It would be assigned the evaluated result of the invocation of multiply by 2, passing in the argument 10. So we would do all of this same nonsense. And instead of passing in 3, we would pass in 10, which would return out 20. The thread of execution would leave that new execution context. We would pop it off the call stack, and that is that. Okay? Any questions about this? Again, the whole point of this was just to get everyone on the same page in terms of technical communication. Juan, am I saying that right?
Yes, Juan.
Spectacular. What is up?
No, that was when she forgot about the call stack, but then she came back to it.
Oh, spectacular, spectacular. Okay, great.
I didn't want to talk while you were explaining, so I just texted.
All good. Love it, love it, love it. Gabby, you have a question?
Is there, I don't know if it's off topic, but is there a better term for garbage collected? I think it's so awkward to say.
Garbage collected is actually the term.
Oh, really?
I'm
I'm
sorry
like
to say.
a recycling kind of person myself, so.
I hear you. I hear you. And be very happy, Gabby, because the memory in a computer is a fixed resource. So even though we're calling it garbage collection, eventually that memory will be reused. So don't you worry.
All right.
Cool.
Better.
Glad to hear it. Glad to hear it. Okay. Any other questions about this before we boogie? No? Groovy. Let's keep on keeping on. So y'all, now that we've established some stuff, now that we have knowledge about functions, about the thread of execution and how it can only do one thing at a time, and we have understanding of execution context, we have understanding of memory, we have understanding of some basic JavaScript functionality stuff, let's actually get talking about asynchronicity. So earlier, remember, I was talking about asynchronicity as anything that is not synchronous or anything that doesn't run in order. Line by line, do 1, then 2, then 3, then 4, then 5. So remember, I talked about JavaScript being single-threaded. Only one command can run at a time. And each line is run in the order that it appears. Okay? So what if, and let's think about this, is there ever a workflow in modern web development where we need to go somewhere else, get some information, wait until we have that information sent back to us, and then do something with it? So let's think about this. If JavaScript just has one thread of execution and can only do one thing at a time, let's say we're going to declare a constant variable tweets, and we're going to set it equal to the evaluated result of some function that goes out and gets tweets at twitter.com/will, and it's going to get the first tweet. Okay. Now, because we have to go to a separate computer, a separate server, a separate location in the world to get this information, we're going to have to just chill until we get information back, right? We're just going to have to wait till we get it. Then we can do some functionality with those tweets to actually display them. And yet this whole time, we have this console log down here that's like, I want to run. I shouldn't have to wait for those stupid tweets. I don't even have to do with tweets. I'm just line 3, but I had to wait almost a whole half second before being executed, which in JavaScript time, y'all, is a lifetime. Half a second is a long time, right? So if we have this single thread that has to go here and wait, and then go here and then process the actual logging to the console, that wouldn't work out very well, right? I mean, think about it. Think about what if you were using Twitter and the entire interface of Twitter were rendered using JavaScript. And when you went to go get tweets, the JavaScript just stopped. In which I mean, there was no visible web page. It was just a white screen and you just wait. There's no spinner, there's no indication that it's loading. You just had to sit there and wait until the computer could do something, right? We wouldn't use Twitter, right? We would have found some other briefer short tweeting service that only lets us, do whatever half of 144 characters are, however many we're allowed to do these days. I don't tweet. But that said, y'all, it's a challenge because if we block the thread of execution, no other code can run. And guess what JavaScript does? Builds our web page or instructs the browser to paint our web page. So what if we were like, okay, cool. What if we delayed it? So, okay, it takes 350 milliseconds or 0.35 seconds to go get a tweet. So why not just put a second delay on something? And then just after a second, then we'll actually display what we're going to get. Can anyone think of a reason why putting a fixed delay on something is not going to be effective? Raise those hands, y'all. I will force you to get your money's worth. Brian, what's up?
Yes, because we don't know when will the task completed, so we cannot use set timeout in this case.
Spectacular. Absolutely. We don't know how long it's going to take. Also, if it only takes 0.35 seconds, that's an additional 0.65 seconds that we're making our users wait. And guess what? Seconds, microseconds in web development time is millions of dollars. Millions of dollars. So we cannot make them wait any longer than we want them to. And just like Brian said, we don't know how long it's going to be. What if it's some really, really weird fluke and the closest server is down and we have to ping one on a different continent and it ends up taking 2 seconds? We're gonna have a total traffic jam. But that said, let's imagine that this is how we were going to do it. Okay? What order, if we look at this stuff, if we were to use set timeout, which is a native function in JavaScript where we can say, hey, delay this function by this amount of milliseconds. So after this many milliseconds, invoke this function and then go on. In what order are our console logs going to occur? Who wants to take a guess? Kristen.
I'll say the me first is going to log first and then the hello.
Okay, great. Why do you think that?
Because it won't, I just know the console log will be faster than what, a millisecond is it? 1 millisecond?
1 second, 1 second or 1,000 milliseconds.
Okay, yeah, 1 second. It'll definitely log before that.
Spectacular. Absolutely. Yeah. So if we're like, here we go, we're JavaScript. Okay, that's just function definition. We hit our set timeout. I got to wait a second, but it's cool. I'm going to just keep going. I'm going to console log this. And let's say 990 milliseconds later, I'm actually going to invoke print hello, which will console log hello. So we would see me first and then hello, right? Groovy. Absolutely. Love it. Now, what if we were to set a delay of 0 milliseconds? Anyone want to take a guess? Anyone who hasn't guessed yet? Adele, am I saying that right?
Yeah, that's right. Sorry,
Spectacular.
chaotic
Don't
here.
apologize for anything ever, Adele.
I think me first will still log to the console first and then hello.
Why do you think that?
I believe that when we get to the line set timeout, that gets put into a queue, and then JavaScript continues to the console log and prints that before it comes back to the queue to do print hello.
Spectacular. Adele, did you tell everyone what happened at the finale of Game of Thrones? Is that your game?
No.
Are you a spoiler?
No.
She did.
All good. No, spectacular stuff, Adele. Adele is absolutely right. Because in JavaScript, it's not actually as easy as just, I'm going to scroll back a little bit, as just waiting and moving on. If JavaScript has this actual single-threaded nature where it can only be doing one thing, it would get stuck here and it would have to stop and wait for 1,000 seconds before it could go on to me first. But Kristen was absolutely accurate that what's going to log to the console is me first and then the hello. Now, Adele pointed out very accurately that what's actually going to happen is set timeout is going to kick print hello off into a waiting room. And it's going to keep going come hell or high water to finish everything else it has to do before it's even going to check to see if print hello is ready to go. Okay? So beautiful job, Adele. Beautiful job, Kristen. Spectacular stuff. Adele, good job swerving around that pothole. Cool. So JavaScript is not enough to accomplish what we want to accomplish. JavaScript itself, where it has just this single thread that can only do one thing at a time, JavaScript is not enough. So the core engine of JavaScript has that thread of execution. Remember, it's got one of them. It has the memory and variable environment, that fuchsia, hot pink global execution context we're using, and then the call stack, which is where it keeps track of what it's currently processing, right? Additionally, in order to make things appear like they're happening at the same time, we have to use all these other components, okay? So we have the web browser API or node background threads. That's where we're going to kick stuff off to wait for a little bit or to sit and think about what they've done until they're out of timeout. We have promises that will make it a little bit easier to do this. We have our callback queue and our microtask queue, which is where things are going to wait after they're out of timeout, but before they can jump back into the game. And finally, the event loop that's going to be checking everything in between. Okay, if that all went over your head, great. That means you're going to grow tonight. So let's take a look. The ES5 solution, okay, ECMAScript 5, used callback functions, similar to set timeout, where we would actually make function definitions that would wait until it was time for them to be invoked. And we would have functions on functions on functions on functions. And at the bottom of our file, we would have a million closing curly braces and closing parentheses. Okay? Now, we strongly believe in understanding not only where we're going, but where we are coming from. So let's take a look at how this would actually work. Okay? So in the bottom left, we're looking at the code that we've already seen. We have already seen what's in pink, and we have already seen what is in cyan. So our global memory environment and our call stack. Now we're going to pretend that this code is being run in a browser. And so the browser makes available to us what's called the web browser API. The web browser API enables some functionality, some additional stuff can happen, including the web browser API has a timer that will count down for us. Okay, JavaScript inherently does not have a timer. The web browser API does. Additionally, we have what's called the callback queue, which is where things go to wait to be put back into the call stack, pushed back onto the call stack so that they can be executed. Now, knowing full well that this might be your first time being exposed to any of these concepts, who is going to look their fear dead in the face and courageously volunteer to communicate through this?
I'll do it.
Spectacular, Jose. What is up? Let's go for it.
All right, so on line 1, we're going to be declaring a function called print-hello, and we're going to store in global memory.
Spectacular. So, and it is a function.
Yep, so we're
What
going to
happens
assign the
next?
function definition.
It's all
And then
good.
we're on line 5.
Great.
So we're going to be sending set timeout to the timer API.
Spectacular. Okay, almost. Let's keep it super simple, okay? What's the first thing we have to do? Because JavaScript sees a function label with 2 parentheses without the function keyword. What do we have to do?
Repeat the question one more time, please.
Yeah, spectacular. The first thing we got to do, JavaScript sees a function label with a set of parentheses, no function keyword, no fat arrow.
We're going to invoke the function. So we're going to invoke set timeout.
Spectacular. We're going to invoke set timeout. Now, Jose, in JavaScript, when we invoke a function, we have to open up a new what?
Execution context.
Execution context.
Laura in Brooklyn, I did not see your lips moving. Were they moving?
They were. Sorry, it's really dark here.
It's all right. It's all right. I'm only here to humiliate every single one of you. But if I haven't humiliated myself enough, just get on the bandwagon. I'm a screaming clown and I'm proud of it. Okay, so Jose, we're going to open up a new execution context for set timeout. Spectacular stuff. When we open up a new execution context, what do we have to do, Jose?
We have to create our local memory.
Spectacular.
We also have to bring inside our execution, our thread of execution.
Great, which means we do what to the what?
We're going to be putting set timeout onto our call stack, pushing it to the call stack.
Great, spectacular.
Then,
okay, cool. And then what?
And then I guess we would pair arguments to our parameters.
Absolutely, we would, Jose, and I wouldn't challenge you like this if I hadn't seen you a million times. So we're going to pair our arguments with our parameters, which in our local memory, we don't necessarily know the names of the parameters, but the first parameter has a value of what?
It's going to have a value of print-hello.
Spectacular, which is
a function definition.
Awesome. And then what is our second parameter?
Our second parameter is going to be 1000 milliseconds.
Great, which just stands for 1 second.
1 second.
Grand. Now we execute it. Now, y'all, I'm here to tell you that set timeout is going to do a little bit of stuff that you are not expected to know today, but you are expected to know about 3 hours from now. Okay, just kidding, we're not going to go that long. But a bunch of stuff is happening under the hood. So what happens is set timeout is actually going to push, this function definition that was passed in. It's going to push it down to the web browser API. It's also going to say, please take care of this bear for 1,000 seconds. Shout out Paddington Bear fans. it will immediately start a timer in the web browser API. But this is over in browser land. The second, the millisecond, the microsecond, the nanosecond that these two values have been passed on, what's going to happen, Jose?
It's gonna get pushed to the callback queue.
Well, hold on. Let me be clear. The second that these values have been pushed to the web browser API by JavaScript, what's the thread of execution going to do?
The thread of execution is going to go back out to the global execution context.
And then what
happens?
happens?
Then we're going to be garbage collecting that stack frame.
So set timeout is popped off the call stack. We garbage collect this execution context. And then what?
And then we pop off set timeout from the call stack.
Spectacular, spectacular. And then what?
And then we go on to our next line.
Grand.
So then we're going to be logging to the console me first.
Great. So we're going to log the string me first to the console. And let's say me first logs to the console at 300 milliseconds. Okay. What happens now, Jose?
So we then check to see if our API is complete, if our function definition is ready to be invoked.
Cool, cool. Let's get a little bit more accurate. What we're actually going to check is there anything in this callback queue? A queue just being a line, just like a line for a roller coaster to get into a concert, something like that. Is there anything in this callback queue? Is there anything, Jose?
There's nothing in the callback queue.
Perfect. Okay, so now it's 301 milliseconds. What do we do now, Jose?
We're going to check and see if there's anything in the callback queue.
Cool. Is there anything in the callback queue?
There's nothing in the callback queue.
Okay, perfect. Okay, Jose, so now it is 302 milliseconds. What do we do now?
We're going to check again and see if there's anything in the callback queue.
Beautiful. We are effectively just looping through, just continuing a loop to check if there are any events that need to be coordinated, right? Think back to, I'm talking about the wedding planner with the clipboard, nervously going, are we ready? Blah, 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 blah. Is there any event that needs to be coordinated? This loop that checks, are there events? Are there events? Is what we call the, don't everyone shout it out at once, the event loop. Okay? This event loop continually checks, is there anything in this callback queue for me to do? Nope. Cool. Is there any more synchronous code to run? Nope. Is there anything for me to do in the callback queue? Nope. So it just keeps checking, just keeps checking, just keeps checking. Now, Jose, let's imagine that it is 1,299 milliseconds after we started. So we have finally elapsed 1,000 milliseconds. What's going to happen?
Our function definition will get pushed onto the callback queue.
Spectacular. So the web browser API is going to push the function definition into the callback queue. It will on-queue it. What happens the next time the event loop checks the callback queue, Jose?
It checks to see if there's anything in the callback queue.
Great. Is there?
Yes, there is.
Okay, and so what happens now?
So the event loop is gonna go ahead and bring that function definition over to our call stack.
Spectacular.
And then we'll be invoking that function.
Beautiful. So if we're going to invoke a function, we have to open up a new what, Jose?
Execution context.
Beautiful job. Just keep
context. Oh, close.
Good. Yeah. Everyone's like, oh God, oh God, oh God, please don't say my name out loud. Okay, beautiful. So we open up a new execution context. Which line of code do we go to now?
The line of code that we're going to go to is line 2.
Spectacular. And so what's going to happen in this code?
we're gonna end up logging to the console hello.
Spectacular. Finally, what happens?
We go back and check to see if there's anything in the callback queue.
Great.
And we notice there's nothing in the callback queue. And that being said, we're done.
We are done. Now we do have to pop this off the call stack, make sure the thread leaves, garbage collect, mindful recycling patrol for those who don't like Gabby. It's all good. I'm sorry, just to be clear, not who don't like Gabby. Those who don't like, comma, Gabby. Cool. So spectacular. Now, can we see why Adele was absolutely accurate, but that if we had a timer of 0 here, it still would have logged me first and then hello? Because what's actually happening in JavaScript, what's actually happening with the event loop is all synchronous code gets executed. All synchronous code gets executed. All of it. Then any queues, such as the callback queue, are checked to see if anything else needs to be executed before we can close out of everything. Okay? So all synchronous code is always going to execute first. So even if we had a set timeout with a wait of 0 and millions of lines of synchronous code, all the synchronous code will be executed first. Cool? Love it. I see some hands. Mario, what's up?
Is it relevant to know where the function definition that wasn't the callback queue, where it went after we logged hello? Is that relevant to know?
You mean it getting garbage collected?
Oh, is that an example of it getting garbage collected then?
Yeah, so garbage collection occurs when there's no longer anything pointing to it in memory. And since the reference on the call stack, I was a little bit unclear, and my apologies for that. The definition isn't pushed onto the call stack. The reference to it is pushed on the call stack. So once that reference to print hello, the reference to the execution context, once it gets popped off and nothing is pointing at it anymore, it gets garbage collected. Now, for those of you who are like trivia buffs, garbage collection is an optimized process that happens at a different point every single time. So we do not dependably know whether it's going to be immediately garbage collected in 2 microseconds, collected 15 seconds later. We don't know. However, we operate as though it gets collected immediately so that we can understand what is available to us in memory or not. Does that make sense? That answer your question, Mario?
Oh yeah, thank you.
Beautiful, of course. Caesar.
Yeah, I just had a question. So with the event loop, but I think I just figured it out. I was gonna say what triggers it, what makes it like stop and eventually like loop out, like because you said it constantly checks within the call stack, and then it goes back to the callback queue to see if there's something there, and it keeps on going and going and going. But I'm assuming that it'll stop checking as soon as it goes back to the call stack, and the main I guess the main I guess we would right here we would call the global memory. The last one is popped out, and then that's what'll make it stop checking, correct? Or is there something else that?
No, absolutely spectacular. Yes, once the global execution context is no longer running, the event loop can rest.
Okay.
Cool.
Yeah.
Love it. Brian.
Yes, I have one question. When you explain after we execute the line 7 and at 300 millisecond and 301 millisecond, we check a lot. I don't think the computer would work that way. Because when we check the callback queue is empty, we do nothing. The JavaScript do nothing. No checking anymore. Until the callback have new content, and it will flow to the call stack and I would be executed. For example, if we set not 1,000 millisecond, we set 10,000 millisecond. We cannot check all the time because the callback queue is empty. So no checking here, and the web browser API will actively insert any available to execute to be executed in the callback queue, and then the JavaScript engine will do its job. I don't think at 301 millisecond it would make a checking.
You are absolutely correct. So this was for the point of illustration. So it's not actually going to be constantly bam, bam, bam. However, if you really want to get super nitty gritty, there are 7 queues that are constantly being managed by JavaScript while it's running. Okay, so we do actually, it is a continual process until the global execution context is actually popped off. The event loop does continue to check each of the queues until everything is finally done.
Yeah,
now,
thank you.
Yeah, of course, the system is aware enough to know if something's in the web browser API that it's waiting to come back, or if nothing's in the web browser API, if nothing is expected to come back, that's when we know that we can pop the global execution context off. That's when JavaScript is done running. But in an environment where we're running and actively waiting for interactivity and for events to happen, the event loop will continually be checking, not necessarily every 1 millisecond. It's not necessarily going to hit the queue. I was just using it to illustrate a point. Does that make sense, Brian?
Okay, yeah, thank you.
Of course.
Yeah.
D, what is up?
Actually, a quick follow-up on the event loop. So does the event loop just check the queues, or does it also check the call stack?
Okay, so it checks whether there is room on the call stack for something to be run and the queues itself. And then when the time actually happens, the event loop will push something to the call stack. Okay, so if all synchronous code is done running, and therefore there's nothing on the call stack that's currently being run, and there's something available in a queue, it will push it to the call stack. Like I said, there are 7 queues, and they have different priority. And we're going to get into that later.
Okay. So then my actual question was, so if you set a timer for like 1,000 milliseconds, so that essentially means like you can't guarantee that it will actually be, like it could be more if there's more stuff happening in the queue. I mean,
it
so
absolutely
like
could.
1,000 milliseconds is like essentially it's like going to wait at least that much time, but it could be like more.
Spectacular, D. Set timeout actually means wait for a minimum of. It doesn't mean execute 1,000 milliseconds after you get here. Cool.
Okay.
Love it.
Thanks.
Love it. Spectacular question. John, what's up?
Hi. Thanks so much, and thanks for your patience with my question here. I'm a little bit of a beginner.
Good.
So for the execution thread, it sounds like with JavaScript, it is single-threaded and synchronous, meaning that it will read each of the components within the global execution context. Or in other words, we'll flow from function print hello to set timeout to console log without reading console log hello. All right, and so my question would be, well, actually, no, I think that's all I really needed to ask is just a clarification question. So thank you.
Spectacular. You're welcome. John, I am going to answer the question that I assume you were going to ask, which is what gives? How am I supposed to know that it's just going to skip over line 2, like it's not even there, but like honor everything else? Am I close?
Yes, that,
Okay.
that sounds about right. And you know, I had thought that with the execution thread that it would read line by line, meaning console log hello before getting to set timeout. But it sounds like that's not the case since it's synchronous.
Correct. So, and this is what I was kind of like noodling Jose about. When we see the function keyword, what this is actually telling JavaScript is I'm about to give you a set of instructions. Don't invoke them. Don't invoke them. But I'm just saving them so that you know for later. Similar to like a parent saying this is, or someone giving you directions to a place. This is how you're going to go. Go down the street, take a right, then take a left, then take another right, and then hooray, right? When we have the function keyword, it just says save everything in here with this label. As opposed to when we see an actual function label with parentheses, we invoke it, which means we actually execute those instructions. So that's why, is it John? I'm sorry, your name just popped away from my screen. Yeah, John. That is why we actually store it in our diagram like this, where we say, okay, it's going to be label print hello. I'm going to take these instructions, store them over in this little definition, and then keep on rocking and rolling. Cool?
Yes, thank you so much.
Beautiful. Absolutely. It is one of the big gotchas of JavaScript. And you're going to see, the more that you start coming to these workshops, you'll start to instinctively say, just like Lindsay said, on line 1, we're going to do a label of this, and then we're going to skip all the way down to blah, 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 blah. It's just a gotcha. You'll get used to it. You're going to feel for it. Cool?
Yes, thank you so much.
Of course. Jose, what you got?
Yeah, so I just wanted to make sure my technical communication made sense in the sense of, so basically I do recall when we invoke set timeout, we did pass in our arguments or our parameters. And then essentially what we ended up doing afterwards was we sent our function definition to the web browser API. Along with it, we sent the delay as well. And then after that, since we already sent out the function definition, then that means we are done with our execution context. So then we proceed to garbage collect it.
Yep.
Pop it off the call stack. And then move our thread of execution back out to the global execution. And then afterwards, we proceed to the next line in which we log to the console me first.
Absolutely. So it's set timeout is kind of a big fat liar, because what it actually does is it invokes and immediately just says, take these set of instructions and wait at least this long, and then set timeout is over. Set timeout gets all the fucking glory, pardon my French, but it's like set timeout is the smart thing that's waiting, blah, 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 blah. No, it just pushes all the work off onto the browser API or to node background threads. And then all of those instructions that were sent over there eventually get pushed into the queue or on-queued into the queue. And then the event loop sends that set of instructions onto the call stack when it's time, and then JavaScript executes it.
Gotcha.
Set timeout does not deserve the credit.
It does. That said, I did have another question as well. I just wanted to know, for the sake of queues in this case, I don't want to spoiler the other queue, by the way, so I'm not going to mention its name, but callback queue and other queue, which name we'll eventually get to, do those queues only house function definitions?
Yeah, what else would you hope that they would house? Just out of curiosity.
I was just curious. That was all. I was expecting functions, but
yeah. They are just functional queues.
Okay.
That just hold on to functionality that needs to be run eventually. Cool?
Cool.
Groovy.
Thank you.
Adele, what is up?
Yeah, so at the point, well, once we get to line 5 and we are sending print hello function definition down to web browser, does that timer start at that point, or does it start once we've finished line 7?
Spectacular. So it starts at that point. So what happens is literally set timeout gets invoked, and it goes over to web browser API and it's like, here you go, here's some instructions, wait this long. And then it just pieces out. And timer immediately is like, okay, because that's its job. It just sits there and waits to start timing something. And so timer's like, bam, groovy. I need to wait at least a second. And then I will put these instructions over in someone else's inbox. That's all timer does. It's crazy. It's a system of things just being like, okay, which is kind of noodling at this really fascinating concept that JavaScript is remarkably capable, but also remarkably dumb. These systems are super dumb. All they do is they're just like, you know?
Got it. So at line 5, once we've handed it over to the web browser, the timer starts right at that point. And then once the timer counts up to at least 1,000, it will send it over to the callback queue.
Yes, once it hit,
or the event to come back and pick it up.
Exactly, and it is predictable. It's not that it waits at least 1,000. It's after 1,000 milliseconds, it on queues that function definition into the callback queue.
Got it.
Now, whether or not the call stack is going to be open and the event loop picks it up yet, that's a completely other ballgame. But all set timeout does is say, hey, web browser API, in this many seconds, push this functionality into the callback queue.
Got it.
Cool? Love it. Love it, love it. Cindy, what's up?
Hi, so I know that in JavaScript there is a concept called hoisting, and we can declare, I guess, variable values later on if we wish to, like after a function definition. So does that mean that we are, so I guess, like, are we reading all the lines first and then storing them into the global memory, and then we see what's in the call stack, or?
Yeah, so that's actually, the two are not related. But what happens is JavaScript has a double parse that happens. So it first goes through and it scans everything, the way that if you were reading an infographic or something like that, where you look and you just scan and figure out, okay, this is a picture, this is a graph, this is some text, this is blah, blah, blah. JavaScript does that once and then goes back up to the top and then actually executes things. So hoisting is a concept that happens where when it sees based on specific keywords, it will actually save function definitions on the first parse. So you can invoke functions before they're defined. But hoisting itself, it can get a little sticky. It's pretty straightforward, but it's specifics that we're not going to get into tonight. But I'm happy to talk to you about it after the workshop.
Thank you.
Cool. Love it. Love it. Love it. Caesar, do you still have a question?
Yeah, sort of. I don't know if it was like kind of answered, but so I know I asked what makes it stop, but I guess I was gonna say but you did mention there's another queue, so I was gonna say what makes it check in the first place? You get what I'm saying? So like you're saying the event loop, or is the event loop only created once the set timeout interacts with the web browser API or like the node thread, being that it's okay, that's the only time it'll be created, and that's the reason why. Okay.
No. I'm sorry. I said yeah to indicate that I understand, not that you were right. You are incorrect.
Yeah, I'm just trying to figure out what makes it check.
Oh, good. Of course. Okay. Of course. To be clear, the event loop is always running. If JavaScript is running, the event loop is running. Okay. It's how JavaScript actually works.
Okay.
And if you're super interested, go look at, there's all sorts of classes on Node, which is the way that we run JavaScript outside of the browser. And you can actually see the way that the 7 queues work and all of that. It's super complicated. But for the level that you're at right now, I'm not trying to discourage any curiosity, but for the level that you're at right now, all you need to know is that the event loop is constantly running. So you always have access to it. It's not something you have to worry about whether it's been started or not.
Got a favorite resource for that, or a book or something?
Yeah, I mean, why don't we talk afterwards?
Okay.
There's actually a spectacular course on front-end masters by Will Sentence himself on Node, which is one of the best things I've ever seen in my life. So cool.
Cool.
Love it. Okay, y'all, let's keep boogieing. So we're interacting with this land outside of JavaScript. When I say this land outside of JavaScript, I mean the browser API. So we're going to need some rules. And the rules dictate how this is going to work. We've seen this exact example. Who was feeling a little timid before because, well, it's full of gotchas and blah, 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 blah. We've seen this exact example, except for that we've changed two things. We've added a function that will block the thread of execution for 1 second. So we don't really care what it does, but let's say it starts a for loop and iterates over an array with 1 million elements in it. And for every element in the array, it adds 1 to a variable. It does nothing. It has a super complicated process that it's going to just run some code and block the thread. Okay. Additionally, we've changed our timeout time to 0. So as Dee did such a spectacular job of clarifying, we have to wait for at least 0 seconds before we can push whatever the first argument to set timeout is into the callback queue. Who wants to attempt this? While you're getting up your bravery, let's remind ourselves, how does the event loop work? So first, it's going to execute all synchronous code. Once all synchronous code has been executed, if everything is off the call stack, if the call stack is empty, then it will start checking queues. If the queue that it is prioritized to has any functionality on it, it will push that functionality onto the call stack. Laura, I cannot wait. I cannot wait to see you work through this. Let's boogie.
So on line 1, you will define a function with the label print hello and store it in global memory.
Beautiful.
And on line 5, define a function with the label block for 1 second and store it in global memory.
Cool. Pay attention to this, John and CO. Okay, keep going, Laura.
On line 9, we will invoke set timeout, which means we'll push it onto the call stack, open a local execution context and thread.
Oh, Laura, don't do it on your own. Don't do it on your own. You are no island. No island. What are we going to do, y'all?
Open a new execution
Execution context.
New execute
Love
context.
it. Love it. Spectacular. Okay, Laura, you are absolutely correct. So we're going to push set timeout onto the call stack. Sorry for the chicken scratch, y'all, but it is what it is. We open a new local execution context, which means that the thread of execution does what, Laura?
It weaves its way in.
Beautiful. Okay, and then what happens?
Pairing parameters and arguments.
Spectacular.
So the callback function is the function definition of print hello.
Beautiful.
And the time is 0 milliseconds.
And the time is 0. Love it. Okay. Beautiful. Now, y'all, just want to make sure we're all on the same page. This function definition is this function definition right here. It's the same thing. Cool? Okay. Now, Laura, what does set timeout do now that it's paired the arguments and the parameters?
So it will send that function definition and that time to the web browser API.
Cool. And what does it tell the web browser API?
after zero milliseconds to send the function, well, hold this for now, and after zero milliseconds, once everything else synchronously is complete, to send that to the callback queue.
Beautiful, beautiful. So let's pretend we have executed how many lines of code? 1, 5, and 9. So let's pretend that we're at 3 milliseconds. Okay, I'm just going to keep track of our time up here. So at 3 milliseconds, JavaScript sends the function definition of print hello to the web browser API, tells the web browser API, I want to make sure that we're clear about this, Laura, because there was something you said that wasn't totally accurate. After 0 milliseconds, on cue, this function definition to the callback queue. Okay? So wait 0 milliseconds and then move it. What happens next, Laura?
So the function gets moved to the callback queue.
Spectacular. Now there's actually a minimum that, depending on the web browser or whether you're running it in Node, even if you put in 0, like the web browser, Chrome is going to wait for 10 milliseconds at least. Even if you put in 0, it's going to wait. But we can just imagine it happens immediately, and there it goes. Now, Laura, here's the super important part. Can we just get it out of the callback queue now?
No.
Beautiful. What happens next?
So the local execution context is garbage collected, popped off the call stack, and after the thread of execution weaves its way back out into the global execution context.
Spectacular. So there it is in the recycling graveyard. It gets popped off the execution context. I'm sorry, off the call stack. What happens next?
On line 11, block for 1 second is invoked, so a local execution context is opened.
Come on, Michael Chan. Help her out.
Local execution context.
Beautiful, beautiful, beautiful.
And it's
Spectacular. Laura's like, I don't want help.
And it's
Cool.
put on the
And then
call
what?
stack.
Spectacular.
The thread of execution weaves in, and then something happens that I can't read.
Nothing.
Yeah, it's blocking for 1 second.
Yeah. Okay, now here's the important part. Remember, JavaScript is single-threaded. And so if we are not doing an asynchronous technique, so we're not using set timeout, we're not accessing anything that helps us do asynchronous functionality, we got to sit here, y'all. Cue Jeopardy song until 1003 milliseconds. And it probably at this point would be 1004. Not here to argue time theory. It's all relative. That was a joke and I wasn't even intending. That said, Laura, what happens at 1004 milliseconds?
The thread of execution weaves its way out of the local execution context. It's popped off the call stack and garbage collected.
Beautiful. Beautiful. Okay. Garbage collected. What happens next?
The console logs me first from line 13.
Spectacular. On line 13, love it. Then what happens?
The event loop checks the callback queue and finds the function definition for print hello and sends it to the call stack.
Spectacular. Now, y'all, the event loop didn't just check, just so we're entirely clear. It has been aware of what has been happening this whole time, okay? But there was not room on the call stack yet. So if the event loop hits the callback queue and sees that something's ready to go, but the call stack is empty, is currently full, the thread of execution is in an execution context, then the event loop is going to wait. So finally, we get this actual print hello definition pushed onto the call stack. What happens now, Laura?
Print hello is invoked, a local execution.
Which means we open up a new
local execution
context.
Thanks, Brian. Appreciate it. Yeah, Laura, I'm sorry. It's just the way we do things. It's all good though. Okay, cool. And what happens now, Laura?
The console logs hello.
Spectacular. Sorry, that's yellow in a chartreuse world. That said, are we done?
Well, the function is popped off the call stack. The local is garbage collected, and then we are done.
And then we are done. Beautiful stuff, Laura. Love it, love it. I hope the chat is on fire for what Laura just did. That was really, really, really good stuff. Now, quick gut check, y'all. Do you see why the discipline of saying the accurate thing that's happening, of knowing exactly what occurs and when it occurs, how it can lead you to look at a code snippet like this that's kind of crunchy. Even, like, honestly, to me, looking at something like this, I have to be like, okay, whoa, hold on, and really think through it. But if you know what JavaScript is doing under the hood, and if you know the actual order of things, it might take a little bit of time, but it's relatively simple to reason about. And that truly is the superpower of someone with good technical communication, who knows what's happening under the hood and can communicate accurately about what's happening. And Laura was just a spectacular example of that. So snaps, Laura in Brooklyn. That said, who has a question? Dee, what up?
I just wanted to clarify a thing with the web browser, with when set timeout moves its callback into the web browser API.
Mm-hmm.
Is that a separate process entirely? Like, so say if it was 50 milliseconds instead of 0, would block for 1 second start? Would that sorry.
All good.
Would print hello get added to the web browser API? Would it get moved over to the callback queue still after 50 milliseconds, even if we were blocked for 1 second?
Yes.
Like, is it a completely separate thing?
Love it. Love it. Such a good question. And yes, it would, Dee. And let me be entirely clear. So when set timeout sends a function definition off into web browser API land, JavaScript is done with it. And JavaScript goes off to keep doing what it's supposed to be doing. Web browser API land doesn't care what JavaScript is doing. Web browser API land is like, I'm gonna follow my directions, and my directions are wait for 0 seconds and then do this thing. And so after 0 milliseconds, I am going to immediately push it back into the callback queue. They are two separate processes. So we've been kind of lying that half of the functionality is not done by JavaScript, it's done by Chrome or Firefox or Safari, while JavaScript is overdoing some other processing. Make sense, Dee?
Yeah, that was helpful, thanks.
Of course. And this is making the distinction of this is we can start seeing the paradigms or the patterns that we use to make it look like JavaScript is capable of doing multiple things at the same time, when in reality, it's just taking the credit for someone else doing the work. What a sneaky. Cesar, what's up?
I must have had the, there we go, sorry.
Oh, old hand, all good. I got old hands too. Older every day. Brian, what's up?
Hello.
Hello.
I just take a look at the set timeout document, and we set 0. That means it would be run as soon as possible. Anyway, I understand this behavior, but how about set interval? It would run at a specific time. How can it inject into the JavaScript when it's running? How it stop and insert
yeah, absolutely.
The things
set
to
interval.
Execute.
Yeah, totally. Set interval is going to be using a different process that is going to completely muddy the waters for everyone tonight. So if you want to talk about it, we can talk about it afterwards. But I want to keep things super clear. Okay?
Okay. Thank
Love
you.
it. Great question, though, Brian. I really, really appreciate it. Okay, y'all. Okay, so this works But response data, so this set timeout, remember we were talking about set timeout as a way to like prevent from JavaScript trying to execute on data that doesn't have a value yet, et cetera, et cetera, et cetera. Response data would only be available within this print hello function definition because we only want to invoke it once the data is back, right? Now it's also callback hell can be difficult for people. A lot of folk think it's not the clearest way to do things. Passing functions into functions into functions into functions just doesn't totally make sense, okay? Now, one of the benefits of this approach is that, just like I said, once we know exactly what's happening, once we know exactly the priority of things, once we know exactly what JavaScript is going to do when and why, it's super, super simple to understand. It's very straightforward. Now, that doesn't mean it's easy. That doesn't mean you're able to do it on first glance. It doesn't mean like, if you don't get this, you're dumb. It doesn't mean anything like that. But it means if you're tuned in and you got all the correct variables in front of you, you can logically reason your way through it, right? That's one of the big benefits. Now, in ES6, ECMAScript 6 in 2015, a big change to JavaScript came out, okay? Now, it was such a big change, in addition to what we're going to talk about and some other new features, that it was so big that we haven't made a significant update to the language since. Let me be a little bit more clear. We haven't made a significant update to what is the modern language, what is accepted as the lowest level of the language since. Now we're technically on ES12, but ES6, the 6th iteration of the ECMA specification, is where we are right now. What it brought to us is what's called promises. And promises enable a lot of this functionality with a little bit more straightforward code that looks a little bit more the way that our human brains think and process. Okay? Now, before we dive into promises, it's been 2 hours. I know it's been a lot for a lot of folks. It's been a lot for me too. We have 6 minutes till it's 8:30. Let's all break till 8:30. Y'all, on your break, check in with your body. Are your shoulders at your earlobes? Is your lower back preventing your kidneys from doing their job? Stand, do old man in the park, do what you gotta do. We will meet back here in 6 minutes. Let's get boogieing. Before we do, I just want to point out that Sherry is shading me in the chat and using the term spectacular. I think I'm actually going to embrace that, and we are going to call things spectacular from here on out. Sherry, thank you. Thank you for being the ethnographer of the night, documenting what developers talk about late in the evening. That said, Sherry, Sherry asked, what is the name for that purple round symbol? Aha, and I assume she was talking about this. Y'all, this is my cheap attempt at the Chrome browser icon. Nothing more, nothing less. If you saw me try to attempt the Safari icon, which is more in-depth, or the, what's it called, the Firefox one, I mean, God help me. I guess I could try the Opera one, which is nothing but that. Look at that, y'all. A perfect Opera icon. Ooh and ah at my artistic prowess. Before we get kicked off on promises, looks like Adele has a question. Adele, what is up?
Hey, yeah, just before we go into promises, maybe could you mention if this older approach has a particular name, or if we just say like, oh, we're using like the callback
callbacks
queue for it.
Literally using callbacks. You'll frequently hear callback hell. That's pretty much it. It's not a there's not like a named approach for what it was, because it used to just be how we did things. You know, it's not, I mean, internet time is back in the day. I mean, like VHS was gone, you know, we were still, I don't think we were even using DVDs at that point, but back in the day, we used to use callback functions. So if you talk about callbacks, folk will know what you're talking about. I promise you, because when we get into promise syntax, oh, no pun intended, I did not do that intentionally. When we get into promise syntax, you're going to see that there's a very different way that we write things. And so just talking about how we're writing them, it's going to indicate that we're using promises instead. Make sense, Adele?
Got it. Cool.
Love it. Oh my God, Cindy. Cindy, what is it with the hate crimes in the chat? What are DVDs? My God. Just make sure if you ever get a chance to see one, Cindy, that you rewind it before returning it to Blockbuster. Waka, waka, waka. Little joke. Okay, y'all. Promises, 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 promises. If you've ever been in a relationship with a human being, you might have some baggage around this term, but it's okay. We're all going to encounter these feelings together. And let's talk about what actually made things a little bit clearer, a little bit more syntactically digestible. Okay, so while I am blathering, feel free to take a look at this code and try to figure out what it might be doing. And then we will definitely verify whether you are accurate or not. So when ES6 created these promise objects, this promise-based approach to asynchronous functionality, what it did was it said, hey, instead of needing to use this callback approach where we have to query for some data and wait for it to come back before we can do anything, what if we immediately create an object that represented something that was going to eventually be data? So instead of having to just hold the phone and wait before we do something, before that data comes back, we create an object that just says, hey, I'm a thing. I just don't have my data yet. So just as soon as I have my data, I will look like data. But until then, I'm just going to be this object. Okay? This placeholder object is what we call a promise. Okay? It just represents, hey, JavaScript, I promise I'm eventually going to be something. But you can go ahead and keep doing stuff, and I can still exist in you because I exist. I'm an object. You don't have to worry about something being undefined. And then you can invoke all of this functionality. And if I am data, then use me. Otherwise, just don't freak out. I'm just going to be data eventually. I'm going to be eventually. So what this promise-based approach also introduced to us is what we call facade functions. So they're functions that look like they're just doing one thing, but they are in reality doing multiple things. So we don't have any line numbers on this code, but let's, oh God, find the Apple Pencil. Oh, there we go, my God. Okay, so let's pretend that we have line 1, 2, 3, 4, 5, 6. We don't even have to pretend, y'all. I just gave you free line numbers. So in line 4, effectively what we're saying, let's pretend that my dog, Lord Regis of Pine, statistically proven to be the cutest dog in the entire world. Don't at me. Let's say my dog has a Twitter account and I want to get his first tweet. It was a cute one, I guarantee it. So what promise syntax has exposed for us is this facade function where we can just pass into the fetch method the URL of the data that we want to access. And what the fetch method is going to do is return a promise object that's going to say, I'm not data yet, but I'm going to be one day. I am going to be one day. Additionally, it's going to trigger an actual browser HTTP request to https twitter.com Regis tweets 1. Cool. And when the data comes back from that, it's going to insert that data into the promise object. Cool. Cool. So if we're looking at the context in which our code is, we have a function definition called display. John in Colorado, if you're still here, check it out. Function definition called display that's going to take in some data, and it's just going to console log that data when the time comes. Cool. Then we're going to create this variable future data and set it equal to the promise object returned by the fetch method, fetching at this URL. Then, once future data has happened, then we're going to invoke the display method and pass whatever is returned from future data, pass whatever is returned there into display without giving the jig away. Look, we have something available. We've named that data. And then our final line of synchronous code is line 6, which is console logging me first. Cool. Spoiler alert, spoiler alert. Just like the previous example, all synchronous code must be complete before any asynchronous functionality can occur. But before we get into that, let's actually take a look at these snazzy promise objects. So the promise object returned from fetch is literally just a JavaScript object. For those of you who aren't familiar, JavaScript objects are a data type where we have key value pairs. So the key would be something like value, status, unfulfilled, something like that. But it could be cat, dog, gerbil, whatever, you know, blah, 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 blah. Just a label that would be set to a value. So a promise object is super powerful in that it is able to update itself and to invoke some functionality. Now, promises have, in addition to a bunch of other properties, they have these 3 properties: value, status, and unfulfilled. Value is eventually going to be what's returned from the facade function's HTTP request. So eventually what comes back from here will be stored in value. But as soon as fetch is invoked, this promise is created and value is undefined. When this promise is created, its status is pending. So that means nothing has gone wrong, but it also isn't done functioning. Finally, we invoke the .then method, which is available on the promise returned by the fetch function. Remember, the fetch function returns a promise, so future data equals that promise. Then we're invoking the then method on that promise, passing in the definition of the display function. What that then method does is fill in this unfulfilled property with the display function definition. That's because the display function definition is passed as an argument to the then method. Cool? Now, what's going to happen next? Well, or I guess what's going to happen first, the console is going to log me first because we must do all the synchronous code first. But then, let's say 350 milliseconds later, 350 milliseconds later, Twitter responds with Regis's insanely articulate tweet that is ARF. When that value gets updated, status gets changed from pending to resolved. And what is in the unfulfilled property immediately gets invoked, passing the promise's value in as the argument. So if we follow that chain, that means the string arf is going to be passed in with the parameter labeled data. And then while display is being invoked, we're going to console log that data. So arf will log to our console. This is a big deal, y'all, because look at how much more semantic it is to say, do this and then do that. Now, one thing that's a little weird about this is it's a little bit less clear that we're using asynchronous functionality. If you didn't know that fetch was a facade function that's actually doing a bunch of stuff behind the scenes, you would think that none of this is asynchronous. We don't see a set timeout. We don't see any indication of an external thing other than this string that's a URL, which indicates that we're going somewhere else, which in JavaScript, if you ever have to go somewhere else, you're doing asynchronous functionality. Cool? Cool. So promises are these special objects that are built into JavaScript that get returned immediately when we make a call to the web browser API that is actually set up to return a promise. So fetch itself is set up to return a promise. That promise acts as a placeholder until we get the data that we expect back. Now, any code that we want to be run immediately on fulfillment, we pass via the then method. That code actually gets put into the promise itself so that once the promise is fulfilled, the promise will actually execute this stuff. Cool? Cool. Let's take a look, y'all. Now, it was nearly spoiled earlier, but we are being introduced to a second queue, which is called the microtask queue. So up to this point, we've been using the callback queue. This new queue we're looking at right now is the microtask queue, okay? Promise-based functionality uses the microtask queue. Anything using the web browser timer API uses the callback queue. Okay, we're going to see why that matters very shortly. Okay, so first of all, does anyone want to try this? Knowing full well that failure is the way to learn, there is no reason to be afraid of failing.
I mean, I'll do it if no one else wants to do it.
Oh, Jose, we got a hand up. Caesar, let's try it. D, you're next. D is next, okay? Numbers up, D. Okay, Caesar, what's up?
So we're gonna start with on the global memory, the thread of execution is gonna go line by line. So it's gonna first go into the function display.
Cool.
And it's gonna store the function definition on the global memory.
Spectacular. And what label is it going to use?
What label is it going to use?
I'll give you a hint. The label comes right after the function keyword.
Oh, display. Yeah.
Spectacular.
Yeah.
So we're saving this function definition in the global memory called display. Okay, grand.
And
then what?
Then the thread's going to move down to line 5.
Spectacular.
We have a variable future data.
Spectacular. Is this variable a constant variable or one that's going to be updated in the future?
It's going to be a constant variable.
Spectacular. How do you know that, Caesar?
The keyword const.
Beautiful. Okay, so where are we going to store this future data variable?
In the global memory.
Love it.
And it's going to be assigned to the do we call it?
You got it. Starts with an E. Eve.
It was what would you call it? A fake function?
Okay. A facade function. Absolutely.
Facade function. There you go.
But we are assigning it. We are not assigning it to a function. What are we assigning? We're actually assigning it to what? The
what?
The evaluated.
The evaluated value? Which
Yeah, the evaluated result of what?
Okay. Of whatever fetch.
Spectacular.
Yeah, so yeah.
So beautiful. So we're assigning it to the evaluated result of the fetch function, passing in a string that's a URL.
Yeah.
Now, Caesar, in JavaScript, when we invoke a function, we have to open up a new what?
Execution context.
Beautiful, beautiful. Kristen is
Execution
full
context.
on hedging her bets. She's like, please just let me say it.
Overpowered right there, man.
Love it. Love it. Okay. So we open up a new execution context.
Correct.
And then what?
Whew. So it's the fetch function is going to be inside the execution context. So now a new thread of execution is going to go down there.
Beautiful. We are in the execution context of the fetch function.
Yeah, correct.
Okay.
And I'm assuming sorry?
Nope, go ahead. You're assuming what?
And I'm assuming that the string the string argument is going to be stored inside the memory for that local execution context.
Spectacular. So since the thread of execution has entered, we also are going to push fetch onto the call stack. But all good. The thread entering, as long as we've indicated it either via the thread or the call stack, we're good. You are absolutely correct, because after we open up a local execution context, Caesar, what is the next very first thing that we do?
The very next thing that we do,
we pair our what with our whats.
Oh, well, we pair the what was it?
One starts with an A, one starts with a P.
Starts with the
arg.
Oh, our arguments with our parameters.
Beautiful, spectacular job. So we don't know the name of the parameters since we can't see the definition, so we'll just call it like the first parameter. And what is the first parameter going to be assigned?
To the string, the HTTP, the URL, which is
exactly HTTP. Beautiful. So this URL. So now this facade function is going to do two things very, very quickly. Okay, and Caesar, I'm going to step in for you to make sure that we're super clear about it. So the first thing that it's going to do is it's going to send off a GET request to the web browser API. Cool. It will also immediately return what type of object, Caesar?
Promise object.
Spectacular. Now this promise object has a value property that starts at what, Caesar?
Oof, I just seen this value property.
I'll give you a hint. The value is not defined yet.
Oh, it's undefined.
Beautiful, spectacular. Okay. Then it has a status of what?
Status.
It's another word for waiting.
Queue.
Close. Beautiful. Great guess. The status will be pending.
Pending. Okay.
And then finally, it's going to have this property called unfulfilled. Okay. Now, Caesar, what is going to go? Well, actually, let's be totally clear. So we've returned this. Unfulfilled is empty. Okay. Because we've returned our promise, what do we need to do with the execution context?
We're gonna garbage collect it.
Spectacular. And when we garbage collect it, we can also assume that it's popped off the what?
The call stack.
Beautiful. Okay, cool. What happens next?
I'm assuming it's doing its thing in the background. So now the thread the thread is going to go down to line 7.
Spectacular.
And now
And do what?
Now we're going to get the which looks like it's we're calling the then method.
Yup.
The variable future data, which is assigned to another function. And we're passing it the display function. Wow, that's a lot.
It is. It is absolutely a lot, but spectacular job, because we are going to save. Just save it right there on the promise.
Yeah.
Cool. Then what?
And then it's going to go down to line 10, which will log me first.
Beautiful. Beautiful, beautiful, beautiful. Now, Caesar, if I were to tell you that things are relatively similar to what we saw in the first half. Okay.
I believe you.
And in fact, I don't even want to say relatively similar. They're quite similar. Just think that we're using a different queue.
Okay.
Okay. Let's say that the web browser API comes back and returns our tweet with the string arf.
Okay.
Okay. The value property of the promise is updated to arf. What are we going to change our status to? It's okay
fulfilled?
if you don't remember the technical term. I'm sorry?
It's probably, I said fulfilled, but
close. Super spectacular guess. It's technically resolved, but yes.
Resolved. Okay.
Okay. So once that status is said to be resolved, what do you think happens now? What are we going to do?
It'll the function that's unfulfilled will get pushed into the micro task queue.
That was beautiful. Then what?
So then does the web browser API thing go into the stack, and then does it get pushed too, or is that something else?
Something totally different. Web browser API, different land.
Cool. Okay, so now the event loop it was constantly checking, and I guess now that it's because it was running, it'll check into the micro task queue if there's something, and then it'll eventually find it, and now that function gets called.
Absolutely. So we'll find it. The function doesn't yet get called. What has to happen before it can get called?
It's gonna get pushed into the call stack.
Spectacular, spectacularly beautiful stuff. This is already garbage collected.
Yeah.
Which function definition are we actually using right now?
The display.
Beautiful. So because it's on the call stack and we're invoking it, we need to open up a new what?
Execution context.
Execution context.
Execution context.
Spectacular. What's the first thing that we do when we open a new execution context, Caesar?
We're gonna assign the all the variables. So starting with the parameters. So we're gonna get the parameter data, which its argument would be the arf.
Absolutely, the arf string.
Yes.
Data is assigned the string of arf. And then what do we got to do, Caesar?
We're gonna move into the first line of the local of the display function, which is gonna call the log method into the console, which is assigned to the argument arf, and then that's gonna get logged. It's gonna get first pushed into the call stack, right? The log.
Nope, just it will log directly to the console.
Okay. Cool. And then
Spectacular.
So then now the thread is going to exit out of the local execution context, which will then pop the display function out of the call stack.
And beautiful. Last but not least, what happens?
And then eventually it's going to get garbage collected.
Beautiful.
And then now the thread's going to finally move into the last, which would be the global execution context, and then finally done. Right?
That's it.
All right, cool.
Say two. Say two. Caesar, beautiful job. Wonderful.
I was a little nervous, you know, forgot a couple of
Good.
things.
Good. I hope you were horrified. I hope your adrenaline was pulsing, because you're going to remember this. You're going to remember this. And that is the only way that we learn, is by making ourselves uncomfortable. Thinking, how could I possibly do this in front of a room full of randos on the internet? I don't know these people. I'm starting to get to know a couple of these folk. But okay, love it. Beautiful job, Caesar. Okay, folk. So can you see what sort of a different syntax we can use? It's so much clearer to say, hey, just go ahead and fetch this, and then when you're done, go ahead and display it. Now, promise syntax exposes all sorts of other things that we can do. So we can chain multiple thens. So do this, and then do that, and then do that, and then do that, and then do that. So all sorts of fun stuff. This just blows possibility out of the water. It's absolutely insane, the things that we can do. Okay? I love it, love it, love it. Now, one thing that's important to know, remember we were touching on this earlier, there's 7 queues. There's 7 queues, my God. And we've only touched on 2. And how will the event loop know? Let's say, I know Kai's like, but hold on a sec. What if there are 3 things on the callback queue, 2 things on the microtask queue, and 80 things on some other queue that I don't even know the name of? Well, the event loop is very, very particular about which queues it's going to empty and in which order. Now, remember that we said that the microtask queue takes precedence over the callback queue. Okay? Just keep that in mind. We're going to go to some questions, and then D is going to put the cherry on the sundae of the evening. Caesar, do you still have a question, or is it hand up? Or is it old hand? Cool. Cindy.
Yeah, so this might be getting a little bit too much into the nitty gritty, but when it's in pending status for the promise object, the value is undefined? Is that what?
Correct.
Okay. So just to make sure, so when we first called the assign future data to the fetch in the global memory, it's
assign future data. Okay.
We're gonna have it's gonna be if I remember correctly, you were doing like a dot dot dot, and then we're gonna have the stack, the environment, I can't believe I forgot this because
it's all good. It's all good. It's all good, Cindy. Totally fine.
So we're gonna have that stack, and then it's gonna return the promise object.
Yeah, so the fetch function does multiple things. So it triggers the browser API to actually go get the data, but it also immediately returns this promise object. And that promise object is returned into the global memory, because we're working in the global memory right now. And remember, we had this actual truthy object. It just had some properties that were undefined. And that's what's so incredible about promises, is that immediately you have a value that is truthy. It's a thing that JavaScript can look at and can actually can move around and do things with. But there are some properties within that object that are just undefined, as opposed to in our first approach, where if we needed data, there was nothing. There was literally nothing to even point at while we were waiting for the data to come back. Does that make sense, Cindy?
Yeah.
So when we invoke the fetch method, it actually opens up a new execution. It gets pushed onto the call stack. New execution context is open. It goes off into the web browser, but also returns out this promise that when that promise becomes data, when the web browser API updates the promise value, then the functionality gets pushed into the microtask queue, and then the event loop is constantly checking and eventually will push that display function to the call stack, passing in the value of the promise as the first argument.
Okay, so I guess it's when we're creating that first execution context where the fetch function is getting pushed to the web API, and also the promise objects being returned and then stored in the global memory. Is that correct?
So yes, the fetch function is not getting pushed to the web browser API. The fetch function, do not apologize. Do not apologize. You are here to learn. The fetch function triggers the browser API and says, hey, take this string, take this URL string that is, sorry, it's way down here. Take this URL string and go do something with it. Go do a GET request is what it's actually doing. Go query this URL. And once you get data back, we'll use a promise to deal with it. Does that make sense?
Yeah, got it. Thank you.
Of course, of course. Any other questions, y'all?
Just to make sure, every time that we invoke fetch, it's always going to be a URL, correct?
Yes. No, there are additional arguments that you can pass to it. Fetch is a native it is not native to JavaScript, but native it's available to the web browser, right? Because it's available to the web browser, you can look on MDN for the actual API reference for it, for the syntax that you use, arguments you can pass, etc. Without getting too wild and into the weeds, if we're not running JavaScript on a browser, we need to use a different package that similarly does the exact same thing. We just don't use the fetch keyword. I'm sorry, I don't want to say fetch keyword. It is not a keyword. It is not a keyword. It is not a keyword. It is a specifically defined function in code that's being run in a browser. Adele?
Hey, so just to do a little compare and contrast with between this our approach with promises versus without promises. If we were not using fetch, if let's say we were in the before time, we would then use, we would still be able to use a get to get hold of those tweets, but we would then have to give it display as a callback function. Is that right?
So similar, yes. What we would need to do is set up a similar callback hell that would be do this thing, and when you are done, do this other thing. But what that ends up creating is like, they call it like the pyramid of doom or callback hell, where all of our callbacks are nested within each other. And the most straightforward way that we can talk about at the level that most folk are at this stage in the game is just delaying this functionality. So just setting a set timeout, waiting for 5 seconds, and hoping that by the time that we come back, that tweets has a value. Does that make sense, Adele?
Kind of.
Kind of ish. Okay, so think about our set timeout function. It was an oversimplified and engineered example that if we were going to actually be using a callback hell approach, we would be using a function different than set timeout, but that would similarly to set timeout take in a function definition, and when it is time, when it's done, when the request has been sent for tweets and the response comes back, then that function definition is invoked. But we wouldn't be using the .then syntax, and we would not be using the fetch method, and it would be crazy ugly. It would be very hard to reason about.
Right, because then if we wanted to do, let's say we wanted to take 5 actions,
Mhm.
we would then need to have action 1 and then we nest action 2 inside of action 1. We nest action 3 inside of action 2, and so on and so forth, right?
Am I sharing this?
Yeah. Yeah, exactly that.
5, 4, 3.
Okay, perfect.
2,
Yes,
1.
that makes
But-
it super clear.
Yeah. Y'all, it truly literally was this. And then when you get into style guides that are each invocation of a function should be on different lines, you would see which, can you see why it's called the Pyramid of Doom? Because they each get indented as the lines go down and down and down. Cool? Great question, Adele. Okay, D. You ready for this?
Uh-oh. I mean, yeah.
Absolutely you are. Absolutely you are. So let's take a look. Let's take a look at this. Poor D. No idea what has been signed up for. So we have a function called display that's going to take in data and is going to console log it. Then we have a function called print hello that's going to console log the string hello. Then we have a function called block for 300 milliseconds that's just going to block for 300 milliseconds. Then we're going to invoke set timeout, passing in the definition of print hello and telling the browser API to wait at least 0 milliseconds before invoking print hello. It's okay, D, it's okay. Just in through the nose, out through the mouth. Then we're going to create a constant variable called future data, set it equal to the evaluated result of invoking the fetch function, passing in a URL as a string. We are going to push the definition of the display function into the onFulfilled property of the promise returned by the fetch function. Then we're going to block the thread for 300 milliseconds, and then we're going to console log me first. At least that's the order of the code. Now remember, we have 2 queues. There are truly no gotchas in here at all. The only gotcha is not freaking yourself out.
Yeah.
We have 2 queues. We have the microtask queue and the callback queue. Promises use the microtask queue. Set timeout uses the callback queue. The event loop is running at all times. And the event loop is going to be constantly checking first the microtask queue, then the callback queue. Okay? Just get that little visual aid in there. Other than that, we have the web browser API, which gives us access to the timer. We have the console, which is where strings are going to be printed. We have our global memory in pink, which is where we're going to save all of these variable names and definitions. And then we have the call stack. D, we're going to do this together. There is nothing to be afraid of. Just be afraid of how glorious you're going to feel once you have tackled this monster. Peace out, Kai. Peace out, Kai. Let's do it. Let's do it.
Okay. Okay. So I guess we start with adding the function definition display to global memory.
Spectacular. And we set it equal to you said a function definition?
Yes, to the function definition.
Okay, then what?
Then we add print hello to global memory and assign that to a function definition.
Okay.
Sorry, it's just a little hard to read.
It's all good.
And then we assign block for 300 milliseconds.
Beautiful.
Memory. Also a function definition.
Okay.
Okay, so then we want to add set timeout to the call stack.
Beautiful. That's exactly what we want to do. Set timeout.
And
Which means we got to do what?
Create a new execution context.
Execution context.
Beautiful.
Execution context.
Okay. And now, D, what's the first thing that happens?
So we want to pair our arguments and parameters.
Beautiful. So what's our argument? 1.
It is a function definition with no label, I guess.
We got a label.
I'm sorry, print hello, sorry.
Absolutely, do not apologize. Okay, so this is our yellow function. Okay, it's this print hello. Cool. And then what, D?
Oh, right, okay. Oh, and then zero is added. That one, I guess, has no label.
Absolutely, absolutely. So we're just using the labels 1 and 2 because we don't know the parameter names. We don't have access to the actual definition of set timeout. The first argument is print hello. The second argument is 0. So groovy. Now D, where does set timeout send these 2 arguments?
So it's going to send that to the web browser API.
Beautiful. And do what?
It's going to just send that there to essentially wait for 0 milliseconds and then
exactly
to the callback queue.
Exactly. So, y'all, we are 6 lines down. So we're going to pretend we're going to start our clock. We're going to pretend that we're at 6 milliseconds. Okay.
So it's going to move over to the callback queue.
Spectacular. Well, hold on.
Okay.
First.
Do we get through all this other stuff in 6 milliseconds or?
Nope. So first, let's take care of closing out of this execution context. So what do we have to do?
Oh, okay. So we have to pop set timeout off the call stack and garbage collect the execution context.
Spectacular. Thread of execution leaves. We are garbage collected. Here we go. Okay, so we're going to pretend that happened in 1 millisecond. That all happened in 1 millisecond. So now
the call stack is empty. So now we actually. So here's a question. So the call stack technically is empty, right? So if we move over the web browser, the print hello from the whichever function that is.
Yep, you're right.
So if we move that over to the callback queue, can that get added or are we?
It can get added to the callback queue for sure. Definitely.
To the callback queue, definitely.
To the callback queue for sure. But remember, there's 2 things that need to be true for the event loop to move something to the call stack. The call stack has to be empty, and all
nothing else to go in it.
I'm sorry, what?
Sorry, go ahead.
And all synchronous code must be finished executing.
Okay.
And we still got 8 lines of synchronous code.
Okay,
cool.
So we don't have to get through all this. Okay.
Yeah, beautiful. So the web browser API pushes the print hello function definition into the callback queue. We're at 7 milliseconds. What happens now? So we were at line 6 in the code.
So we're moving on to line 8.
Beautiful.
Where we add future data to global memory.
Love it.
With the result of invoking the fetch function.
Beautiful. Which is what?
That will be a promise.
Spectacular. Now, technically, what's going to happen is we're going to open up a new execution context. It'll get pushed onto the call stack. All good. You're doing great. Future data will.
So many things. So future data will. Okay. So future data will
be equal to what type of object?
Oh, it's a promise.
Beautiful, spectacular. So it returns this promise object, and it also does what, D?
Oh, so it's going to send that fetch call to the web browser API.
Beautiful. Beautiful.
Is that a function, or is it just like a kind of a query kind of thing, or?
It's literally what it's going to do is send a string to the web browser API and say, do a GET request with this, and the web browser API will take care of the rest. It'll actually create a query and send it to another server and wait for everything to come back. Cool?
Okay.
Beautiful. Okay. Crazy, right? So that the promise that has been returned has a value property. What is it?
It's undefined.
Beautiful. It has a status property of what?
Pending.
Absolutely. And it has an unfulfilled property of?
Undefined.
Yep, for right now. Absolutely. Cool. Beautiful. Now what?
I'm sweating. Oh my God.
All good.
Okay. So we are done with fetch now. So we can pop that off the call stack.
Absolutely.
And dispose of that execution context.
Disposed. Okay.
And then future data dot then is invoked.
Absolutely. And what does the then method do?
So that
where does it
assign the display function to be the unfulfilled
oh my God. Yeah.
property of the promise.
Oh my God. I hope the chat is literally bursting into flames right now.
So that literally doesn't
okay, D.
until you call dot then. Okay. That makes some sense.
Cool. So then what?
Oh God, there's more. Okay.
Oh God, there's more. Oh God, there's more.
So wait, the function that's the unfulfilled, right? Or is that the value?
I'm so sorry. Yes, absolutely. 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 It goes into unfulfilled. I'm sorry, real estate is at a premium.
Okay.
Beautiful. So now what?
So now, okay, so block for 300 milliseconds gets pushed to the call stack.
Yep, absolutely.
We create a new execution context for it.
Spectacular. Block 4, make a new execution context. It just runs.
Just runs and
So let's say that 250 seconds elapse. So we're at, I'm sorry, milliseconds. So we're at 259 milliseconds. And the response has come back from the web browser API.
Oh, right. That's in there. Oh, so, okay. So that value from the web browser API goes into the microtask queue.
Beautiful. So the value from the web browser API goes into the value property on the promise.
Oh, the value property of the promise. Right. Okay.
Returned by future data.
Oh, okay. And then the display function goes into the microtask queue.
Spectacular.
So the value goes to...
Okay, great. So now is where we're starting to see the real beauty of this, y'all. You can see how the system is like locked and loaded, and yet we still have other things to do. So then D, more time passes, we get to 309, which means that block for 300 milliseconds is done.
It's finally done. And then we pop that off the call stack and garbage collect that execution context.
Spectacular. So now D, let me make sure this is out of here because we're done with this. Okay, so what happens now?
So now we console log me first.
Beautiful.
So if there's nothing inside that, like if it's just a one-liner like that, it doesn't have to get onto the call stack, it just gets executed.
You mean the console log?
Yeah.
So technically what happens is there is an internal method that does get executed, but we don't clutter up our diagramming of the call stack with it. But technically we're invoking a log method on the global console object, but it gets a little over the top, if that makes sense. So, but absolutely, D, we're gonna console log me first.
And then
we're done, right?
Well, there's still some stuff waiting in the
Damn right.
Event loop's doing its thing, right? Checking tasks. So it's gonna.
What's the first thing that it checks?
The microtask queue.
Spectacular. And it sees what?
It sees the display function.
Spectacular. Now, what is the two things that it has to make sure of?
That's a good one. That the call stack is that there's room on the call stack. And
Spectacular.
There's nothing else waiting. There's no more synchronous functions waiting.
Spectacular. There's no more synchronous code that needs to be executed. So D, is there anything on the call stack?
No.
Is there any more synchronous code that needs to be run?
No.
So what is the event loop going to do?
So it's going to pop the display function onto the call stack.
It's going to push it.
Push, sorry.
But do not apologize. We will literally give you all of the dispensation necessary because you are doing spectacularly.
Can I just want to go back to one thing real quick?
Yeah.
I forgot to change the status of the promise to
absolutely
whatever it is supposed to be.
To whatever it is. It is going to change to resolved.
Resolved, thank you.
There's so little. I'm also working, y'all, just so you know, my iPad screen, I can only write on that big of it when I'm using this program. So that's why I look like this serial killer note. Okay. Spectacular stuff, D. Okay. So we have, let's see, we've pushed display onto the call stack. So that is going to open up a new what, D?
Execution context.
Execution
Beautiful.
context.
Love it. Okay, so what's the first thing that we do, D, when we open a new execution context? We pair our what with our what?
The parameters and the arguments.
Beautiful. And in display, how many parameters do we have?
Display, we have one.
And it's called what?
I do not remember when. It's what came back from fetch, right?
So the parameter is the placeholder.
Oh, the parameter for, can you zoom out again?
Display.
Sorry.
Yeah.
Oh, okay. The parameter for, okay. So display is the actual parameter.
Display is the function that we're invoking.
Wait, oh yeah, sorry,
It's all good. It's all good. This is what always happens. You do so well on the hard stuff and then you're like, I don't even remember what we're talking about.
Okay, so we're in display. Okay, so data is the label.
Beautiful. Data is the parameter. Okay. And what is it set to?
To display.
It is set to, okay.
Oh God, sorry.
It's all good. No worries.
I got a little lost. Okay.
Absolutely. You used everything that you got to get through the hard stuff. So remember, a promise is going to automatically pass its own value property into whatever definition is on unfulfilled. It will automatically pass it in as an argument. So its own value property, exactly. So data in the local execution context is assigned to the string arf. Cool?
Yeah.
Beautiful. What do we do now? Remember, we are invoking the display function.
So we're console logging that.
Correct.
Console logging arf.
Okay. Then what happens?
So we write, okay, that happens. Then we pop that function off the call stack. And we kill that execution context.
Okay, and then what?
And then our event loop sees that there is something in the callback queue, which thank God you color coded these, which
Right?
is the print hello function.
Love it. So it goes up onto the call stack.
And that goes on the call.
Sorry, I'm not gonna.
We create a new execution context.
And what's the first thing that we do when we open a new execution context?
We pair the arguments and the parameters.
Yep. Do we have any parameters on this one?
There aren't any.
Correct. So what do?
We just console.log hello.
Spec.
And then I start.
Accurate. That was a beautifully. Oh wait, we got some more stuff to do. What do we got to do?
So we pop that function off the call stack and we garbage collect that execution context.
Absolutely. Y'all, snaps for D. That was so spectacular.
That was nuts.
It's nuts, isn't it? It's absolutely wild. And the thing is that, my God, we didn't even make it a second. That wasn't even a second. And it took our brains quite a while to figure it out. And this is the really cool thing, where JavaScript is remarkably dumb, but amazingly capable. We are remarkably smart, but amazingly incapable. We can't make computations as quickly as JavaScript can. And JavaScript knows its own rules. It knows exactly what it's going to do. It's never going to be like, well, in this case, I'm going to do blah, blah, blah. No, this is just what it does. So learning that this is how things happen, this is how it works, this is what's actually happening under the hood, when you're out in the wild, quote unquote, of either the immersive residency or your job as a senior developer, you're able to use these skills to actually go through and figure out, oh my God, that's why we're having the error. Because in this instance, it's using the microtask queue instead of the callback queue. And it's being pushed too soon. It's wild. It truly, truly is the difference. Now, some of the problems to know about this, just to be aware of, a lot of folk don't know how this works. And that's okay. You can still get a job not knowing what's exactly happening under the hood, but it makes debugging really, really, really hard. Also, the way that they establish in the interview process, whether you are a senior level engineer or not, is not by testing you on things that you're going to actually use on the job. Not at all, in fact. They're going to test you on things that only working for a long time in JavaScript and learning these idiosyncrasies that you're going to know. So throwing a set timeout in a for loop, and that set timeout console logs the value of I, but within a for loop. What is it going to do? Well, spoiler alert, I won't be incremented on the first console log. In fact, it won't be incremented on any of the console logs. Or, depending on where you put the set timeout, it may increment the number of iterations, but it's only going to be the final value of I by the time that it's logged to the console. So you get the number 5 logged to the console 6 times. Check it out. It's wild. It's wild. So anyway, the whole reason I'm telling you this is that that is the way that they're going to actually assess you. So knowing this stuff is going to be spectacular. You can give a spectacular interview. Y'all, some of the benefits: it's cleaner, readable style, pseudo-synchronous style code. It looks like synchronous code, but it's functionally asynchronous. And it has a beautiful error handling process, which we didn't get into tonight. But if there were an error in this asynchronous call, we can set up, instead of a dot then, we set up a dot catch and then pass in the error and do something with the error instead of console logging the result, maybe alerting the error or triggering some different functionality. That's beyond the scope of tonight, but that's one thing that promises enable us to do. Cool, Adele, I see you. I absolutely see you, and I will be there very shortly. So we have rules for the way that this works, and having those rules makes everything predictable. The most important thing to know is how the event loop is going to prioritize these things and at what points things are going to be run. So we're going to push stuff to the call stack if it's empty and if all of our global synchronous code has already been run. We are also going to prioritize what's in the micro task over what's in the callback. Cool? Cool, love it. Now, finally, hooray, we have accomplished our original quest. We started out as 43, I think, and we're down to 31. But we have accomplished our quest. We can delay functions running until the work is done and the data is available. We have not blocked. We don't have to wait. We can keep rendering stuff to the page, maybe render a spinner, make other parts of the page interactive, even though we don't have the data back. And the second that we get the data back, we can trigger functionality as soon as JavaScript is capable of running it. Again, this is the backbone of all modern processes. Cool. So what's next? We have all sorts of career workshops that are free. We have more JavaScript, the hard parts.